The last oligopoly model that we're going to look at for this chapter is the Stackelberg model or Stackelberg competition. So far, we've only considered the case in which competitors with market power choose output or price simultaneously. In reality, though, firms make decisions before or even after observing a competitor's choice. That's what Stackelberg competition is. It's an oligopoly model in which firms make product decisions sequentially, so one after the other. Just like before, we have some model assumptions that we have to talk about. Again, the firms make identical products. Like the Cournot case, they compete by choosing the quantity to produce. All goods sell for the market price, which is determined by the sum of quantities produced by all firms in the market. However, firms do not choose their quantities simultaneously. They do it one after the other, having seen the other firm's choices. So basically, it's exactly a Cournot model, except now the firms choose one after the other. So consider the outcomes from the Cournot model. Each firm chooses its optimal quantity based on what the firm believes its competitors might do. So what happens if one firm observes the other producing more than the Cournot output? They could punish their competitor by changing its own production. Uh, Reaction curves, those quantity functions that we saw, are downward sloping, and so the best response is to reduce output from the Cournot equilibrium level. The ability of a first mover to manipulate its competitor's output in Stackelberg competition means that there's a first mover advantage. So, by changing their quantity in that reaction curve, in the previous video we talked about Saudi Arabia and Iran changing their quantity and what the other would do in response. Now we have a situation where one gets to make that decision first and the other has to respond. And so the one that makes that decision first has an advantage. In Stackelberg competition, the advantage is gained by the initial firm in setting its production quantity. So let's talk about that Saudi Arabia and Iran case again. Inverse demand is given again by 200 minus 3 capital Q, and capital Q equals the sum of the quantities produced by Saudi Arabia and Iran. Each country has a constant marginal cost of $20, and the countries will produce where marginal revenue equals marginal cost. That gives us the following reaction functions. Again, we have a marginal revenue curve for Saudi Arabia of 200 minus 6 times Saudi Arabia's quantity minus 3 times Iran's quantity. Set that equal to the marginal cost, which is equal to 20. And so Saudi Arabia has this reaction function, QSA equals 30 minus 0.5 Q1. This should look very familiar. It's the same as before. Iran has the same thing. Their reaction function ends up also being QI equals 30 minus 0.5 Q. Now suppose that Saudi Arabia gets to move first. This means that it chooses its optimal quantity before Iran does. Iran's incentives remain the same. For any quantity that Saudi Arabia wants to produce, Iran's reaction function describes the same optimal response. However, Saudi Arabia realizes that Iran will do this before it makes its first move. So Saudi Arabia's reaction curve is different. Specifically, we have to substitute Iran's reaction curve into the inverse demand curve. What does that mean? We have Iran's reaction curve there. We're going to take it and substitute it into our inverse demand curve. So P goes from equaling 200 minus 3 times Saudi Arabia's quantity minus 3 times Iran's quantity. Now it's P equals 200 minus 3 times Saudi Arabia's quantity minus 3 times Iran's reaction function. We're plugging that reaction function in. We can solve then, simplify. So price equals 110 minus 1.5 times Saudi Arabia's quantity. Remember that the marginal revenue function is double the slope of the inverse demand curve, and so Saudi Arabia's marginal revenue curve is equal to 110 minus 1.5 times 2, or 3 times QSA. Set that equal to marginal cost, which is equal to 20. Solving, you should get the quantity for Saudi Arabia is equal to 30. Now we can plug that 30 into Iran's reaction function. So QI equals 30 minus 0.5 times 30. So Iran's quantity equals 15. Let's compare the results between the Cournot and the Stackelberg case then. We have this inverse demand curve for the Cournot case. Saudi Arabia's marginal revenue function looks like this. We set it equal to 20, which is the marginal cost. So the quantity for Saudi Arabia is equal to 30 minus 0.5 times Iran's. Once you go through and solve everything, like we did in the previous video, the quantity for Saudi Arabia ends up equaling the quantity that Iran produces, which is equal to 20. In the Stackelberg case, though, we have that additional complication. So the price is equal, the inverse demand curve gets substituted in. So we have price equals 200 minus 3 times the quantity of Saudi Arabia minus 3 times Iran's reaction function. Simplifying again, we end up with a case where we set Saudi Arabia's marginal revenue function equal to the market marginal cost. So Saudi Arabia's quantity is 30. Plugging that in to Iran's reaction function, Iran's quantity ends up being 15. So in the Cournot equilibrium, each country produces 20 million barrels a day. Now, though, Saudi Arabia produces 30 million barrels per day, and Iran only produces 15 million barrels a day. The total market output is higher under Stackelberg, under the Stackelberg model, but the profits for Saudi Arabia will be higher. So let's compare the profits. Again, we have the same profit function. It's the quantity that Saudi Arabia produces times the market price minus the marginal cost. Saudi Arabia produces 30 units. The price is equal to $65 per barrel. And so solving for that, Saudi Arabia makes $1.35 billion a day. Iran, same thing, except they are only producing 15 million barrels a day. And so it's 15 times the market price minus the marginal cost. So Iran's only making $675 million worth of profit each day. Saudi Arabia then makes slightly more profit than the Cournot equilibrium per day. This is strictly a function of its first mover advantage. Iran, meanwhile, does much worse. So when one of the competitors has this first mover advantage, there's huge additional profits that can be made by the firm that moves first, and much lower profits for the firm that moves second.